I don't know if you can hear me.
Yes, loud and clear.
Okay,
Good morning,
perfect.
Francesca.
Good morning. Welcome to all the participants to this webinar session in the occasion of the third launch of the E-waste Challenge massive open online course. This session will focus on critical materials, e-waste recycling, and climate change. My name is Francesca Cenni, and I will facilitate this session on behalf of the BRS Secretariat, as well as providing a brief introduction to the 2025 version of the MOOC. In today's session, which is scheduled to last for 1 hour, after an initial introduction, a presentation will be given by Ms. Elisa Arteaga Prieto on behalf of Professor Karen Van Acker, who is a professor in circular economy at the University of Leuve in Belgium. It will last for about 40 minutes, and it will be followed by a questions and answers session for about 15 minutes. The presentation and the recording will be posted on the website of the Basel Convention in the webinar pages. It is my pleasure now to present the learning path and the courses which are included in the E-waste Challenge MOOC, and I will change my presentation. I hope you can see it. Yes, okay, good. So the E-waste Challenge MOOC is developed in partnership between the BRS Secretariat, the EIT Raw Materials Academy, a knowledge and innovation community established by the European Union, the University of Leuven in Belgium, the International Telecommunication Union, and the World Resources Forum, which is a Swiss tank on sustainable use of world resources with the collaboration of the World Health Organization. The new version of the MOOC is hosted on the FutureLearn platform and is available in English and in Spanish. The participants can obtain 5 certificates for each of the courses and an overall certificate. The learning journey of the MOOC starts with course 1 on the E-waste challenge with an introduction to e-waste issues, impacts, and solutions. Course 2 focuses on e-waste and children health, presenting the latest knowledge on human exposure to e-waste from dismantling, recycling, and final disposal. Course 3 on reducing e-waste by design standards, business and policies, focus on policies like EPRs and ITU standards on e-waste. It is designed for policymakers and regulatory authorities. Course 4 includes principles for inclusive and sustainable recycling of e-waste, best and worst practices, and materials traceability standards in secondary extraction of metals from e-waste. This course is designed for recyclers in developing and developed countries. Course 5 on e-waste management standardization and conformity assessment is new, and it is directed to recycling facilities wishing to receive e-waste certification different types of certifications, as well as to auditors and accreditation entities. So you can access the MOOC from this page. And today I have the pleasure of giving the floor to Elisa to start her presentation. Elisa, you have the floor.
Hello, good morning, everyone. I will share my screen now. Okay. Can you confirm that you see it?
Yes, we can see.
Yes, we can see.
Thank you so much. Good morning, everyone. Today, I am Elisa Arteaga. I am a researcher in the University of Leuven, the Catholic University of Leuven. And today I will be presenting this exciting topic about the connections between e-waste, critical materials, and the environmental impact they have, mainly with the message of encouraging you to keep learning about this topic and all the opportunities there are to contribute. So the presentation is going to be divided in 4 parts. Firstly, presenting the research challenges. Secondly, what are the environmental impacts associated to the extraction of these resources? What are currently strategies that the governments and business are managing in order to provide these resources to the society, as well as the challenges and opportunities regarding business and supply chain? To finally conclude with some remarks. So let's start. We know that in the last couple of decades, we have been seeing a lot of transitions. The 2 transitions that we're going to focus on in this presentation are the energy and transport transition and the digitalization transition. The world is demanding currently other sources of energy in order to reduce dependency to fossil fuels. This is mainly due to geopolitical aspects, dependence on certain countries that produce oil and gas, but also due to environmental pressure. The second challenge is that we currently live in a digitalization era where technologies are emerging, which seem to be very contributing and very supportive for problems that we have now. For example, artificial intelligence can support many areas of science, but also businesses, or other type of industries and knowledge, such as blockchain. However, we need metals for this to happen. The energy transition is a commodity transition, and as the world decarbonizes, we need more and more metals. Here we can see a comparison of the projections of metal demand until 2050 when analyzing the current climate policy to which many countries have adhered. And on the right side, what will happen if the countries adhere to the Sustainable Development Goals. And here we can see a clear difference between the two. In order to achieve climate neutrality, around 80% more metals will be needed. A similar thing happens with the digitalization, which is also commodities transition, as many materials are needed in order to improve the digital performance, increase data storage capacity, and provide higher speed interconnectivity. Here are some examples. For example, silicon is needed in the microchip, which has a huge market and is expected to grow every year in the coming decades, reaching finally around 180 billion of US dollars of market size. Also, memory and logic devices which contain cobalt are in rise on demand, as well as magnet and semiconductors that contain rare earths in themselves. But of course, all of this need is associated to some geopolitical dependencies. Currently, the world, these metals are only produced in certain parts of the world. We can see, for example, the lithium, which is required for batteries, has been mainly extracted in 3 countries the last decades, leaving only around 15 to 20% to the rest of the world. A similar trend happens with copper. Well, copper is mainly better distributed, but we can see that the dependency is even higher in the case of rare elements, where China is dominating the extraction of ores. But not only the extraction is a critical point when we are analyzing metals. Also, it is the processing to metal. And here we can see that there is even a stronger dependency, even a stronger global dependency on China, given that this country has been improving its technology during the past decades and now has a lot of refining capacity for copper, even more for lithium, dominating more than 50% of the market, and is the main refiner of rare elements. Of course, this is not favorable for other countries, and as we can see, definitely not for Europe, which can be disrupted at any time. So, this extraction of metals has some environmental impacts and also some social impacts, which we are going to analyze now. In this talk, I would like to encourage you to keep a life cycle thinking perspective, which means consider that when an ore is found, it mainly looks like this, and it can be tons of ores that reduce to a small amount of gold. In this case, we can see an gold ore and how it is extracted, for example, for semiconductors. From tons, we end up with 40 kilograms of gold, which is deposited in the microchips, and only around 100 grams end up from all this extraction ends up in computers. So we can see there that we have processing, refining until it gets to the user stage. And after several years of use in the form of a computer, it will finally break and its lifespan will conclude, generating e-waste. This is called a life cycle thinking, which includes all the different steps that a product will undergo. Here we can see 2 examples for a phone and for electric vehicles and combustion vehicles. In the case of the phone, during this study, it has been seen that 80% of the impact of the greenhouse gas emissions were coming from production, whereas only 16% came from customer use. And this study analyzed also the recycling, which produced only 1% of the emissions. However, this changes radically, for example, for cars, where we can see that the production, the manufacture of the vehicle itself is way low compared to the use phase of the car. And this is currently the case for combustion vehicles, and we can see that the electric vehicles are more efficient regarding the use phase, but this is expected to shift as more and more electric vehicles are demanded. So let's go into the first stage, let's say. The extraction and production of critical minerals has grown in the last decades, not only in amount, but also in percentage of the total global emissions that are emitted to the atmosphere. And the main sources of this were about raw material extraction. The main sources of pollution were iron, steel, aluminum, and other metals, which are the topic of this talk. Cement and non-metallic minerals, as well as plastic, rubber, and production, are the other contributors. So, in the life cycle thinking, something that is also important to keep in mind is that not only the CO2 emissions are analyzed and studied, assessed, but also other important categories besides global warming potential, such as particulate matter formation, marine ecotoxicity, mineral resources. All of these impact categories are associated to some damage that can be perpetrated either to other species besides the human, but also to human beings. And what is analyzed in a life cycle assessment through the perspective of a life cycle thinking is the damage that is going to be perpetrated in human health, in ecosystems, and in the availability of resources for future generations. Having said this, we can continue to the second phase of the life cycle thinking, let's say, which is the use phase. The digitalization transition comes hand in hand with energy consumption, being the two topics that we have started the talk with, highly interconnected. Together, they are staggering 40% of the carbon emissions worldwide. And this is expected to continue growing as digitalization is reaching more parts of the world. Here, as an example, we can see how for example, the deployment of networks or data centers has less than 1/3 in this case of emissions compared to the use phase. This is mainly because these networks or data centers are expected to have a very long lifespan in which they are going to be consuming a lot of energy. So, finally, as we mentioned, every product that contains these metals, and in particular in this case for e-waste, is going to reach an end of life. And that means we're going to be producing waste that ends up somewhere. In the last 9 years, we can see that there has been an increment of the total e-waste from 44 million tons to 62 million tons. And new types of e-waste has been created, as for example, as the case of photovoltaic panels, which was not there in 2016, but as plants that were commissioned in the 90s or the early 2000s are starting to be closed. We see that new type of e-waste is generated. And for other type of equipment, we can see that the amount of waste has increased almost in double. This trend is expected to continue, and by 2050, the amount of e-waste is expected to double. On 2024, however, only 22% of all this e-waste has been recycled, which leads us to the question, what happens to the other 80%, well, around 80% of e-waste? Well, that e-waste ends up in dumping or in land or water bodies, or is shifted to other continents where it is dismantled or burned. This, of course, poses a big threat to human health, mainly due to the exposure to toxic content. What happens is that these metals or these batteries, for example, they are encapsulated in complex chemical matrices, which could lead to acid leaching when these are manually disassembled. The sector that is most vulnerable and highly affected are, of course, children, because children are often involved in waste picking and scavenging, and they are also used for disassembly due to the small hands and the ability to access small parts that can be found on e-waste. On 2021, the World Health Organization analyzed the amount of children working on this and realized that around 16 million children are involved. Finally, not only humans are highly impacted by the end of life of e-waste or the supply chain of metals, but also there is a big biodiversity impact. The countries being more vulnerable regarding mining of these metals can be seen in this graph, where not only the amount of mining is taken into consideration, but also the value of the ecosystem itself, the biodiversity, but also the country's intent and capacity to protect these areas. Biodiversity can also be affected by the e-waste, as previously mentioned, by the acid leaching, for example, or by the ingestion of small parts that are not properly taken care of. So now that we have settled the problematic of this topic, and we know that the demand is expected to be growing, we will like to discuss what are the strategies to secure resources for electronics and for everything, for every product that will underpin the transition for energy and digitalization. There could be some strategies such as mining, better and stronger trade of these materials, perhaps more recycling or material innovation. So, metals are very valuable and their value continues growing because they are natural source base is degrading. Here we have the example of copper ore grade, and we can see that in the early 900s, the average grade of the ore was 3%. But in 1 century, we have already mined all the high content ores, and a project is considered nowadays economically viable or technologically viable, even when it's around 0.3%, which is pushing us to farther and farther every time, and which definitely poses a risk, a challenge in terms of technology. I would like to present the case of Europe, as our research group works here. So, is it really possible that more mining can supply all the demand? Well, Europe has a large mining project pipeline, but also quite uncertain, especially for lithium and rare earths. For other metals such as copper, zinc, or nickel, potential projects will mainly compensate for depletion of existing minings instead of major new growth. However, we can see that there are metals for which there are no expected mines, and therefore a lot of challenges regarding self-sufficiency. And these are exactly the ones that are quite critical, such as cobalt or lithium. But what will happen in case of refining? Okay, if there is a better trade of ores, there are better projections in case of self-sufficiency regarding refinement. Lithium and nickel refinery plants have been announced in the past years, but more refining announcements will be needed in order to get a strong self-sufficiency for mature markets. But however, we can see still for some critical metals for transition, Europe still faces a legitimate risk of metal production if they don't encourage more recycling, for example, which is coming next. So, really relying on import for this refining is not the best strategy. Definitely not in the short term. Some projections have been carried on for the current commitments that nations have done and for sustainable development goals. And we can see here that for this decade, there are not enough projects to meet the demand, especially for electric vehicles, for example. However, the long-term plans and plans that have been set seem more encouraging and seem to have potential to meet the demand by 2040. So, but there could be other options when compared to the traditional ones. And that's when circular economy comes into the story. A circular economy is a pragmatism in which the value of materials is maximized as long as possible in the economy. So, avoiding that the material loses value, market value itself. The input of primary materials, virgin materials, is minimized, and the generation of waste is as well minimized. And in the circular economy, we not only consider the material production and the material value, but also this is highly interconnected to minimizing negative environmental impacts throughout the whole life cycle. So, how are new resources demanded? We, in the circular economy, let's say, in the research group, we focus on covering societal needs. The societal need could be, in this case, for example, transport, which will be covered by a car or by public transport, bicycle, whichever example you can think. But any product that will be used to cover this demand will need materials and resources. So, keeping in mind this perspective, we can see that there are several strategies to reduce the new resources demand. One of those could be recovering the value from waste. So, a new source of these materials or resources. Another source could also be renewable raw materials. Well, in the case of transport, let's say, this is already happening because non-renewables such as oil and gas are being disencouraged in the population. Another strategy could be the design for a more resource efficiency, so lowering the amount of resource needed to cover the primary societal need. In the perspective of the product itself, we could also extend the lifespan or give a more intense use to the products or create other type of supply chains. So let's start with the recycling potential, recovering value from waste. As I mentioned, there is a shift from using fossil fuels, and one of the strongest, let's say, advantages is that contrary to fossil fuels, metals have properties, physical properties, that make them highly recyclable. So we can see, for example, that the global average of copper recycling is 45%, which is already very good because that can cover some part of the demand. Here we can see, for example, how the amount of secondary copper has been covering around half of the total global supply already. And this is expected to be rising because as recycling business get more funding, financing, they can invest in better technologies and optimize this and transform the recycling rate to an even higher share. This is, of course, very good because we can see here how much of the primary demand can be leveraged by this secondary market, which, as mentioned before, not only is high, but is expected to be rising as recyclers continue improving the rate. And this is true not only for copper, but also for other important metals for the transition, such as cobalt, nickel, and lithium. You can see here that the projections for the cover of the demand with recycling are quite optimistic. The more mature markets are, of course, traditional metals such as aluminum, copper, and zinc. But from 2030 onwards, we are situated here, not only the demand or like the market capacity is expected to grow, but also the technological capacity, improving these numbers significantly. And how is this connected to e-waste? Well, e-waste has a huge value potential in terms of total metals that can be found on them. We can see here that there are megatons of iron, aluminum, copper, and nickel lying around all of us in cables, computers, phones, and household appliances. Not only base market metals, but also other metals that are expected to grow, to have a market grow in the coming years, but also precious metals, which contain high values such as silver and gold. And of course, linked to this, we also encounter environmental gains. The potential reduction of CO2 emissions is big. If you can see here, almost reaching the 60% of the current emissions, so with a decrease of 40%. We can see here, for example, the case of copper and aluminum, which I describe as very strong markets, but also established technologies, where the reduction of CO2 footprint is drastic. And this is, of course, very good news for all of us because emissions can detriment our health. What happens in the case of the less efficient recycling technologies? Well, as I mentioned before, these are currently not in a mature level because there is not a huge market push. But all technological research points out that this can also be lowered significantly as more innovation, like more investment to deploy innovative plans is given. But of course, there are a lot of challenges regarding recycling. It's not all good news. The first challenge is increasing complexity. We have to keep in mind that traditional mining handles few metals in an ore. Normally, one ore contains predominantly one metal and traces of a limited amount, let's say 5, 4 other metals. However, electronic products contain several metals in each of their parts. For example, we can see here how many are involved in circuit boards or semiconductors. And separating them becomes a challenge. But not only the intrinsic complexity of the product plays a role, but also the reverse supply chain, which loses efficiency in every process. For example, collection of the e-waste could be improved, as well as the dismantling process, how to separate the little parts that are only glued or screwed, which of course requires a lot of time, and time translates to labor, which translates to money. Finally, one of the biggest challenges will be the recovery final processing, which has challenges associated not to physical or reverse logistic, but to chemical aspects on how can we separate these without creating contaminants. And then the question comes, do we prefer quality or quantity when recycling? Because to achieve a higher quality, more specialized chemical treatment is required. but that also assures and guarantees that the material can be reused for the initial intended use without losing monetary value. However, when quantity is selected, and massive amounts are treated without rigorous treatment, then there can be an accumulation of contaminants, which leads to being able only to use the metal for lower value applications, which is called the downcycling effect. Other influential factor for better recycling that can be outside of technology would be, for example, a better design that allows dismantling or separating the product in an easier way. Also, better collection with incentives to the public to give back their funds. How many of you that are listening, for example, have old computers or old phones in your drawers? Because there is not an incentive or a good collection system. Finally, material flows knowledge from the part of the government could influence this a lot, as they will know exactly what is going into their territory, what amount of value is currently as stocks in the country, and how can this be translated into business opportunity. Another influential factor to be kept in mind is the price and the value. So currently, not only a big amount of metals is lying there, but also a huge amount of estimated value, which in 2022 reached 91 billions of USA dollars, for example. From which the main part comes from copper, iron, gold, nickel, and aluminum. Value and money of these metals is a big influential factor because currently there is a big volatility on the prices. You can see here only from 2019 how much the value has been fluctuating. However, when there is a market of secondary materials, this can create a buffer, or knowing the stocks within a country could create a buffer in order to counteract this. But not only recycling is, let's say, the best strategy in order to leverage this big demand pressure. There could also be other strategies that allow to reduce the pressure of demand of metals, but also reduce the CO2 emissions of extracting these materials. Here we can see, for example, that demand reduction will be the most efficient strategy. But this could also be coupled with intensified use or life extension. And using these strategies does not mean that there won't be that the value, the market value, or the employment created by the primary extraction of metals will be left, because there is also big potential to employ people in intensified use, life extension, repair of the metals, repair of the electronics, and there's a big potential for this. Here I would like to show the example of how the primary material demand of steel could be lower. Here we have a current baseline projection of how much steel in tons is needed for passenger kilometer. If there will be material recirculation, meaning recycling, this could be lowered by 29%, by 0.29 tons. When introducing another circular strategy, mainly material efficiency, like efficiency in production processes, creating less scrap, efficient parts and design, we could also reduce the demand of primary steel. And here we can see that the most effective strategy would be as having a circular business model. A typical European car is parked 92% of the time. Why not share it? Why not demand for another business model that allows this amount of steel to be intensively used? This would lead to a reduction of 66% of the demand of primary steel. But also there are other benefits, monetary benefits for the user. These are mainly related to infrastructure, parking, land occupation, the cost of congestions for governments, for logistics of decongesting streets, and some other externalities like accidents and pollution. So, as you can see, in this, providing everything needed to cover the societal need, there are several strategies, but also there are several opportunities to contribute in the whole story that I just told. Many different professionals are needed, not only experts in metals, but also people involved in data-driven designs, collection of data, legislation, design for the manufacturing, modularity, reusability, people creating legislation or monitoring in the governments, and also entrepreneurs or economies, business managers to analyze markets potential, and create new business models that can cover this demand. So, thank you for your attention so far. The concluding remarks are, we have a big need, but there are solutions and opportunities. The need is obvious that as ambitions grow stronger, we will need more materials, and there is currently a resource scarcity. Well, there's not a resource scarcity currently, but there are projections that point out a resource scarcity in some sectors, but there are several solutions. There is not one silver bullet, but a combination of business models, market innovation, and new value chains. And there are a lot of opportunities where people can be involved in understanding all these material flows, consumer behavior, and of course, how to lower the environmental impact of our consumption. Thank you so much for your time. All the resources are there all around us, not only as ores, but also in our houses, in our environment, in our infrastructure, train infrastructure. So there are a lot of innovation opportunities. Thank you so much for your attention. I think now we can proceed with the questions.
Yes. So thank you, Elisa, for this very encompassing presentation. And I will now open the floor for questions and answers. And in the Q&A session, if you wish to take the floor, please click on the raise hand icon in the menu React. And once you've been given the floor, unselect the hand icon by clicking on it again. When given the floor, remember to unmute your microphone and mute it back after the question. And then if you want to send the questions in writing, you can type them in the Q&A tab or in the chat. And then I open the floor now for the questions. Perhaps I start. No, there is.
Yes, we have one raised hand, Dr. Samuel Moses. You can unmute yourself.
Thank you very much to the team for very wonderful and insightful session. I have two questions. One regarding very specific to the presentation, and maybe I missed something. That's why I'm asking. I don't remember which section, but there was in one of the slides, there was this statistics about how recycling has reduced carbon footprints from different metals, and I think was like 96% on aluminium. I just wanted to be sure if that was specific to Europe, or like where this data is calculated from. And that follow up my question. Where is the global South in this transition? And I'm talking very specifically because I do research on E-waste in East Africa, and I don't see the industry moving to that direction. So yeah, that's just my question. Thanks.
Regarding the first question, that slide refers to technological potential. It's not the reduction per continent or from market, but is technological potential. So the amount of the CO2 emitted for a traditional, let's say, extraction and refining process versus the best available technology currently for aluminum, for treating aluminum from the market. So it's not a total from any part, it's more a case study, let's say, of the best available technologies. Regarding the Global South, it's a very interesting question. The Global South has to understand that Europe and US are more protective than ever of these secondary sources. So as we saw in the slides, historically, e-waste was sent to Africa and Asia, and there, let's say, informal tradition ways of recycling were used, which were associated to a lot of health problems and contamination problems. However, they also were source of employment for some people, informal employment. So, as this is shifting to a formal way of treating waste, a lot of value is expected to be reduced from these developing countries. We should keep in mind this. The Global South, therefore, has to create stronger alliances in terms of markets with the producers themselves in order to see what is their position going to be if they cannot access e-waste treatment. I think that's all I have to say. If you have any other question.
I cannot see any questions in the chat, and I cannot see any raised hand. Yes, one raised hand.
That's me again. I have a follow-up question.
Okay, please.
Yes. Yeah. So I'm still a little bit wondering how, of course, I really like how you categorize the needs, challenges, and opportunities regarding to proper recycling of e-waste, but also potential. So that was very insightful. But you know, because I work in East Africa, I still because there is, which I think is a challenge, and I would like to hear your opinion on. So there is what I see as a movement. So the population is growing in the global south. Disposable income is also growing, which means there will be more consumption of electronics, if we talk about all kinds of electronics, which means they are discarding. They will become waste. There will be even more waste produced in the global south than everywhere else, and I will talk specifically to East Africa. How does this, the growing population, the movement from rural areas to cities, and increasing disposable income, because countries are moving to lower, middle, and middle income countries, but also they lack all the infrastructures for e-waste, from collection to recycling. So how does this portray the picture of the opportunity for the future that you have just presented? So I just wanted to add on that.
Yeah, thank you so much. So I think the population growth and consumption growth is portrayed on the statistics on how much e-waste is expected to rise in the coming decades. In one slide, I said that in 2050, the world is expected to have around 120 megatons of e-waste, which is an enormous amount. Of course, there are two, regarding the movement of citizens to cities, this is connected to the idea of urban mining. So traditional mines, where are concentrated places of places with an ore concentrated on material. An urban mine actually acts in the same way. All of this value is concentrated on the urban environment. It's just like we don't have the capacity, like the collection capacity to manage urban spaces well. But as more and more population are concentrated in cities, of course, the amount of metals dissipated in that, let's say, technosphere is growing. So there will be business potentials. But more than business, I think this is a combination of legislative and business collaboration opportunity, because the user, like the owner of the e-waste, has to have an incentive to give it back, in order to move this, because currently there is no incentive in the cities to recover this. Also, new design of infrastructure probably will be needed. One of the examples that has been seeing lately is railway stations of old metro stations that have a lot of copper and steel cables, but were not designed in a way that is easy to extract them in the middle of a city. So that's another opportunity for redesigning and taking this into consideration. And the global south, well, it faces a lot of challenges, no? I think currently there are no obvious countries that are leading the recycling market. So global south already has a bit of knowledge of how to dismantle this, how informal waste pickers were handling this trash. So it is encouraged to governments to approach this sector, to approach the informal sector, and also learn from their experiences and cover their health demands. Provide, for example, better filtering masks or gloves for the workers, because their source of income cannot be immediately leveraged somewhere else as formal recycling. It will have to be a slow transition, but meanwhile, government or investors can benefit from their knowledge from the last decades and at the same time give back something of value in order to accelerate this market.
If I'm not mistaken, there are no more questions, but we see that maybe some participants want to send questions by chat, but it was not possible or easy. The Q&A tab works, but we are coming to the end of our webinar session. And for this reason, I invite you to contact the or presenter directly or send us the questions you may have. We'll try to answer by email. I would like to thank again Elisa for her encompassing presentation, for speaking on behalf of Karel Van Acker today. And I would like to remind you that this session will be repeated in Spanish on Thursday, 9 October at 3 p.m. CST. And Elisa will be presenting again in Spanish. I would like to remind you that next week we'll introduce course 3 on reducing e-waste by design standards, business and policies on Tuesday, 14 October in English, and e-waste and children health in Spanish on Thursday, 16 October. We will now close the meeting, and I thank you all for your interest and for your participation. And many thanks again to Elisa and to Artem, who's been helping us with the connection and with this session. Thank you to all.
Thank you, everyone. Keep curious, keep learning. And goodbye.
Bye-bye.
We have one raised hand, just in case. Juvenal. Juvenal, you can unmute yourself. We've just sent the request to unmute, but something doesn't work.
Yeah, I also sent. I think it might have been a mistake.
Okay.
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 So thank you so much, and see you again for next sessions and next session in
See you
the
on
day
Thursday.
after tomorrow. Thank you, Elisa. Thank you so much.
Bye. Bye-bye.
Bye-bye. Bye.